Hey guys, what we're going to be looking at today is graphing linear equations. So what we've done is we've looked at two forms. We have looked at slope-intercept form, which is y equals mx plus b. And this is awesome because we have the slope, which is the rise over run, and we have the y-intercept. The second way we've looked at is standard form. Standard form was ax plus by is equal to c. And this is great because we get the x and the y-intercept. And those are the only 2 points we need, and we just graph them and connect them. So what you get to do, guys, is look at the equation and determine, is it in standard form? And if not, is it in slope-intercept form? And if not, is it easier to convert it into standard or slope-intercept form? And then you're going to graph it. So let's go over how we graph these. Now looking at this equation, I have 3x plus 2y equals 12. It looks like it would be a lot easier, since it's already in standard form, just to keep it in standard form and solve for it. So what I'm going to do here is I'm going to find my x and my y-intercept. Remember, to find your x and your y-intercept, for the x-intercept, you plug in 0 for y and solve for x. And on the y-intercept, we're going to solve it again by plugging in 0 for x and solving for y. So let's go ahead and find the x-intercept first by plugging in 0 for y. This will look like 3x plus 2 times 0 is equal to 12. From the other videos, you should know we can just kind of ignore that now because I'll be left with 3x is equal to 12. I'm going to divide both sides by 3 to get x is equal to 4. So that's the mystery number right here. So my first intercept is my x-intercept, which is 4, 0. So I'm just going to plot it right here on my graph. Now the second one, I'm going to solve it again. I'm going to do it in red. I'm going to do it to the right over here. I'm going to plug in now 0 for x. That's going to look like 3 times 0 plus 2y is equal to 12. I'm going to ignore that 3 times 0 because 3 times 0 is 0. And 0 plus 2y is just 2y. So I really don't need to look at that. And what I'm going to do then is divide both sides by 2 to have y is equal to 6. So I'm going to have 6 right here. And that's my y-intercept, which means I go over 0 and up 6. Now I can easily just connect the two lines. So here is the equation of that line. And it's just going to connect the blue and the red point. So once they're connected, last part of the equation, it asks for the slope. And remember, slope, that's just another word for rise over run. So all I need to do is, starting at the red point, count down 1, 2, 3, 4, 5, 6. And since I went down -6. Now I'm going to go to the right. I'm going to go to the right 1, 2, 3, 4. So I have a rise over run of -6 over 4. And I just look at that and see if it can reduce, and it can, to -3 over 2. All right, now looking at this next one, this is not in standard form. And you got to decide, would it be easier to solve it into y-intercept form, slope-intercept form, or standard form? I personally find it easier to convert this equation into slope-intercept form. Now I know it's a habit to distribute that 5 to each term. In this case, what I want to do though is divide both sides by 5. I'm going to divide each and every term by 5 because I'm going to try to get y by itself. This will give me y plus 2 is equal to x over 5 is equivalent to 1/5 x. I write it this way because it's easier to see your slope, your rise over run, plus 3. I'm then going to minus 2 on both sides to get y is equal to 1/5 x plus 1. So looking at here, remember this constant at the end is our y-intercept. It is 0, 1. That's the point. So my y-intercept is just 1. My slope is the coefficient of x, which is 1/5. Now to find my x-intercept, I'm going to have to graph this. So what you always do when you're given slope-intercept form, which I am right here, you start at your y-intercept, which is 0, 1. Now, what I'm going to do is graph a few points. So my rise over run is up 1 over 5, up 1 over 5, up 1 over 5. Now it doesn't really help me with finding my y-intercept So what I can do, instead of going up positive 1 over positive 5, I can also go down 1 and to the left negative 5, because a negative divided by a negative equals a positive, so it'll still be a point on that line. So if I go down 1 to the left 5, down 1 to the left 5, you can see that those points, it will still makes a straight line. For whatever reason, if you graph these points and it doesn't make a straight line, that means we made a mistake somewhere and you're going to have to double check where it is. So I can draw my straight line connecting those points, and you can easily see my y-intercept, and you can now see my x-intercept, which the point here is 5, 0. So for my x-intercept, it is 5, 0. So now let's go ahead and look at this. You get to decide, is it easier to put this in slope-intercept form or standard form? So if I distribute the negative 2 to both sides, I will have y plus 5 is equal to negative 2x. A negative times a negative is a positive 2. You can then, for me personally, I see it easier of subtracting 5 on both sides, and I'll get y equals negative 2x minus 3. Now right here, I'm given my y-intercept, which is a constant, which is negative 3. And my slope is negative 2. And for us for those of us who forgot, my rise over run would be negative 2 over 1. You don't need that divided by 1, but it helps us out a little bit with graphing. So I go to my y-intercept, which is the line that goes up and down, and I go down 1, 2, 3, and I plot a point right here. And to find the next point, I just do my slope of going down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. Now, similar before, it's hard to see what my y-intercept is because I'm going down. So what I can do is then go the other way, which is up positive 2 and to the left negative 1. Because remember, a negative divided by a positive is a negative, and a positive divided by a negative is also negative. So I can go up 2 over 1, up 2 over 1. And all these points should line on there. So once I draw the line, I want you to notice something, that it's pretty hard to see what the x-intercept is. So there's one more thing I can do. Remember, right here, I'm trying to figure out my x value, but I know my y value is 0. So what I'm going to do is look at this equation. I know that my y value is 0, and I need to solve for x. So I can do that by just getting x by itself. I'm going to add 2x on both sides to get 2x is equal to negative 3. I'm going to divide both sides by 2 to get x equals negative 1 and 1/2, or negative 1.5 works. And if you see that, here's negative 1 and negative 1/2. It lines up pretty well. And to be even more accurate, I can just move my graph over just a tad, and you can see it hits it right there at negative 1.5. So right here, my x-intercept is negative 1 and 1/2. That one was a trickier one, so if you have trouble finding your x-intercept, let me know. All right, so let's go ahead and look at this one now. It's almost in standard form, so I feel silly converting it to slope-intercept form. So what I can do here now is do a a fraction buster by clearing the fraction. And I can do that by multiplying by the least common multiple, which is 4. This gives me x plus 4 divided by 2 is 2, and 2 times y is 2y, is equal to negative 4. Now that I have this equation, I'm going to ignore what they gave me and just focus on the x plus 2y equals negative 4. And I want to go ahead and find out my x and y-intercept. As a quick reminder, remember the x-intercept is when your y value is 0, and you're trying to figure out that mystery number. So let's go ahead and plug it in, y for 0. So x plus 2 times 0 is equal to negative 4. I don't need to look at that. I'm just going to be left with x equals negative 4. There's nothing left for me to solve, so I just have an x-intercept of negative 4, which I can plot right here on my graph. So 1, 2, 3, 4 right here. So then I look at my y-intercept. I'm going to do the same exact thing. I'm going to have x plus 2y equals negative 4. But if we remember on a y-intercept, I'm trying to find my y value when x is 0. So in the equation, it's going to look like 0 plus 2y is equal to -4. And I don't need to pay attention to that 0, so I just divide both sides by 2 to get y is equal to -2. So I go down to -2. And since it asked me to graph, I'm going to connect my lines. And now that I have a graph, the easiest way to find slope is just do your rise over run. So I always find the rise over run from left to right, so I'm going to start with my blue point and make my way to my right point. So to do that, I just do rise over run. I go down 2. Since I'm going down 2, it represents it by a -2. I'm going to go to the right 1, 2, 3, 4, to the right 4. So it'd be -2 over 4, which reduces to -1/2. All right. So now what we're going to do is we're going to look at a graph, and we are going to write that in slope-intercept form, and we're going to convert that slope-intercept form into standard form. So there's two things. On slope-intercept form, remember, I need to find my m, which is my slope, and my b, which is my y-intercept. So let's start with the easier of the two, because we can see it right there. My graph goes through the origin, which means my b value is 0. So that's easy enough. Now all I need to do is find my slope by just doing my rise over run. So I'm going to do my rise over run, remember which is your slope, which is the variable m. And we're just going to go up 1, 2, 3, 4, 5. So I just rose 5. And I'm going to go over to the right 1, 2, 3, 4, 5. And 5 over 5 reduces to 1. Therefore, in slope-intercept form, if we remember this is my m, and just a quick reminder, slope-intercept form is y equals mx plus b. You always have a y equals my m, which is 1, times x plus my b, which is 0. This would then simplify to y equals x. You don't need the 1 in front. You could if you'd like, and you don't need a plus 0. Now in standard form, what we need to do is, if I'm given y equals x, I am going to subtract y on both sides, because remember your x variable, your x coefficient needs to be positive, and I'm left with 0 equals x minus y. Now it looks like it's done, but there's one more step. It's a little silly, but we need to do it. You need to have the x and the y on the left side of the equal sign and the constant on the right. So it would be x minus y is equal to 0. One thing I want to help you guys out with is graphing special case scenarios. This is x equals -1. What that is whenever you have an x equals with no y, you are going to have a vertical line that goes up and down. It's just the rule. It's kind of like having a slope of up 1 over 0. And what you do is you go to that x value. So it says x equals -1, which is located right here. And since it is x equals, it's going to just be a vertical line. It's kind of like having, yeah, I'll just leave it right there. Anytime it's x equals, it's going to be a vertical line. Like I said, you go to that value on the x value, which is -1, and you just draw a vertical line. Now the next special case is y equals 9. Anytime you have y equals 9, it's going to be a horizontal line. Horizontal line. Those are the ones that go left to right. So same idea, it's y equals 9. So we go to our y-axis of y equals 9, which is located right here. And all we are going to do now is draw a horizontal line going from left to right. And then we're done. All right, if you guys have any questions with any of these, whether they're the special case scenarios or any of the others, please let me or your teacher know.